Hi, in this video we are going to learn quadratic inequalities. Let's start with an example. Find the set of values of x for which x squared minus 2x minus 3 is less than 0. Now, when it comes to thinking about functions, we have y, right, equals, let's say, x squared minus 2x minus 3. So the question is, we are looking for those y values being negative, right, basically, because this bit means y, right, this is a function, so we are looking for wherever y is negative. Now, we can solve this inequality by using graphs, right? Or tables, we can make a table, or we can use direct algebra. So there are three ways that we can use to solve this inequality. Now I'm going to show each one of them quickly, and we're going to try another example later on. Now, if we'd like to use graphs, this is what we're going to do. We solve this as if it's an equation and find the roots. These roots are now called as critical values because they are the border of our inequality. So basically, if we consider this as an equation and solve it, the roots that we find are called as critical values. And if we draw the graph, we're going to have something like this, where, well, this is the y-axis, of course, and this is the x-axis, right? So you can see the roots marked here, minus 1 and 3, right? So we now are looking for the x values that give me a negative value. When I substitute an x value here in the inequality, I should get a negative number for y. This happens only in between the roots, because when I choose 1 for x, right, the value is negative 4. When I choose another value for x, I find the negative value of y. As long as I stay in between the roots, the critical values, I always get, say, a negative y value. When I exceed the root, for example, if I choose 4, I find something positive. If I choose a number from here, I find something positive, which I don't want. So basically, in between the roots, give me negative values of y, as you can see, right? So I'm going to write as a solution set, it's going to be negative 1, x, and 3. So negative 1 greater less than x less than 3. This is going to be my solution set. So that's the answer to this inequality. So this is the set of values of x which satisfy the inequality. Now we can also make a table. We can say, of course, we have to solve the equation first. And once we know the roots, we are going to draw a number line sort of thing. It's going to be minus 1 and 3 here. So I will have my columns like this. And here, I'm going to write one of those factors. It's either x minus 3 or x plus 1. It doesn't matter which comes first. But then comes the function x squared minus 2x minus 3, right? Now, I am going to fill in this table with signs. What happens is that x minus 3 becomes 0 when you substitute 3 here, right? So before that value, or smaller values of x, will give me negative values when I substitute here. So, for example, if you substitute 0, it's 0 minus 3, which is negative. So the numbers to the left of that 0, right, will be negative, and the numbers to the right will be positive. The same applies to x plus 1. Minus 1 makes this expression 0, and values of x smaller than minus 1 gives me negative values if I substitute here, and bigger values of negative 1 will give me positive values. Now, you can see that x minus 3 and x plus 1 are being multiplied here. So that's what I'm going to be doing. Minus times minus, right? This is minus and this is minus. Minus times minus makes plus. Minus times plus makes minus, right? Plus times plus makes plus. So, of course, I'm going to consider that this expression becomes 0 for both of these values, minus 1 and 3. That's obvious, right? Because these are the roots of this expression, this function, right? So what happens is if you multiply numbers from this region, minus times minus, so negative numbers, two negative values multiply out to a positive number. One negative, one positive value multiplies to a negative number, and two positive values multiply out to a positive value. So what I'm looking for is that I'm looking for negative values. So I should be considering this region where x is in between negative 1 and 3. So once we find the roots, we make a table and consider the signs of the values in each region here, right? And then we just go multiply the signs, meaning multiply the values, of course, but trying to find the sign of these values, and we choose whatever the question asks us to. So that's how it works. Now, this is slightly bigger work, I should say, compared to graphs. So we can use simple algebra to get rid of this too much of work. Now the idea here is simple. Again, I'm going to consider this as if it's an equation and solve it. So it's minus 3 and 1, right? So I factorize it like x minus 3, x plus 1, right? This is going to be less than 0. So I keep writing an inequality here. Or maybe I should say the inequality, right? So I keep on writing the inequality here. And I know that if I multiply two numbers and get a negative number, why? Because it's less than 0, then I end up with saying one of these numbers must be negative. So it could be that either x minus 3 is negative and x plus 1 is positive, because one negative, one positive numbers multiply to a negative number, right? Either it is x minus 3 which is negative. In that case, x is less than 3 and x is greater than negative 1. Or it's going to be x minus 3 greater than 0 and x plus 1 less than 0. This means x is going to be greater than 3 and x is less than, say, negative 1, right? Now, which of these is possible? Is it this or this being possible? Let's check this out. Can x be less than 3 and bigger than negative 1? So this is an AND situation, right? So we are looking for a possibility that x could be bigger than negative 3. Sorry, I wrote it wrong. I have to write this like negative 1 and 3. Right. So x is less than 3 and x is bigger than negative 1. So yes, it is possible because we are talking about this region in between these numbers. So this is possible. Now let's look at this second possibility. X is greater than 3, so x must be greater than 3, right? And x must be less than negative 1. Well, this is impossible, right? X cannot be greater than 3 and at the same time less than 1. So this doesn't make sense, so we don't consider this. So our answer is this. So I could write my answer being in between -1 and 3. So this is the algebraic argument of solving an inequality. So you can choose whichever you'd like, but you must show, work to end up with the solution set that satisfies the inequality. Another example. Right, in this example we have two parts. In part A it says find the set of values of x for which 12 plus 4x is greater than x squared. And in part B we have to find a set of values of x for which this inequality and this inequality are both satisfied. Now, let's go with part A. I'm going to make this a quadratic expression which the other side would be 0. So I'll have x squared minus 4x minus 12, which is going to be less than 0 because I take these to the other side, right? So it must be less than 0. In this case, if I factorize this and solve, I'll find the critical values, the roots, right? And then I can just draw a graph to find the set of values of x. As I need the negative values for y, I'm going to choose the x values which are in between the roots, because here the graph is under the x-axis, so the y values here are negative. So my answer to part A will be that it's going to be -2 less than x less than 6. Now, let's look at the second part. Certainly I need to solve 5x minus 3 is greater than 2. Well, that's going to be 5x is greater than 5. And then x will be greater than 1 if you divide both sides by 5. Now, let's look at the number line. Here, I have the solution set for the first inequality being -2 to 6, right? So this is my solution set to the first inequality. The second inequality suggests that it's going to be, let's say this is 0, this is 1, right? It's going to be bigger than 1. Now I have to look at the intersection of these two sets, because the idea is that we're trying to find the set of values of x which satisfies the quadratic inequality and the linear inequality. So I have to consider this region, right, which intersects, which overlaps, that satisfies both inequalities. So actually, my answer to part B would be, this was 1, this was 6. 1 less than x less than 6. Right, this will be my answer. Now, this example is interesting because at first instance, when you look at the inequality, you just think that, fine, we have this x in the denominator, so if I multiply both sides by x, right, I can cancel these out. I'm going to have 6 greater than 2x. That's not a quadratic inequality, so I can solve this. I can say, this is over 2 over 2, so basically x will be less than 3, and that's the solution set. Question. X is less than 3, meaning I have this bit being positive values of x, so if this is my solution, but this bit is negative values of x. What I'm trying to say is that while multiplying both sides by x, we don't know whether x is positive or negative. It's not mentioned. Here it is mentioned that it's not going to be 0, because otherwise this fraction would be undefined. But it doesn't say x must be greater than 0 or vice versa, right? So I have no slightest idea what the sign of x is. So I have to consider multiplying both sides by x squared. Why? Because x squared is always positive regardless what x is. So I'm going to have 6x here, because if I multiply the fraction with x squared, x's will simplify, there will be only 1x left, so it's going to be 6x greater than 2x squared. Now, taking 6x to the other side, I'm going to have 2x squared minus 6x less than 0. Now I have the quadratic inequality. So, taking 2x as a common factor will give me x minus 3 here, less than 0. Now, I can say either x is less than 0 and x minus 3 is greater than 0, because one of them must be negative so that you'll have a negative value, or x is greater than 0 and x minus 3 is less than 0. So let's test this. Well, if x minus 3 is greater than 0, x will be greater than 3. Now, it is impossible to be a negative number and bigger than 3 at the same time. So this option does not make sense. So I have x is greater than 0 and x is less than 3. This makes sense. On the number line, right, I have this solution. Right? X is less than 3, x is bigger than 0. So basically, I can write this. So, if you were to multiply both sides by x and end up with x is less than 3, you can see that's only a part of the solution, right? But the real solution is this. You have to be choosing x to be positive. Needless to say, you could use graph method or table method to be able to figure out the solution for this inequality, right? So, just a quick addition before the exercises. Now, when you have your graph drawn, right, this is, let's say, y equals f of x. If you're asked to write down the set of values of x which satisfies y is less than 0, it's going to be in between the roots because these values are negative in terms of y, right? If the question says find the values of x for y is greater than 0, then it's not going to be this region, right? It is going to be the exact opposite, because these values of x will give you positive y values, right? You can see that these values of y are positive. So in that case, you should be writing, for example, here this is minus 1, this is 3. You should be writing x is less than minus 1 or x is greater than 3. Obviously, this cannot be and, because x cannot be less than negative 1 and bigger than 3 at the same time. So you should be writing or. But if this is the case, if the function is given to be positive, then you should be marking on your graph this part of the graph, right? Because these are the y values which are positive. And you should be writing your solution like this. Now, please solve these questions on your book and submit your answers online. Thanks for watching.